Now let us go through the question 47 of second chapter of Zettili in second edition. So the question is given that we have two operators, position and momentum operator, and we are asked to calculate, or we are asked to prove this two particular thing where P is parity operator and N is an integer. Okay, so before we move ahead with the solution, I would recommend you to go through the parity operator, that is 2.6.5 parity operator, page number 128. Please go through this particular section before we move ahead with the question, and specifically in that equation 2.345. This is a very important equation if you are planning to go ahead with the question. So the equation states that this parity operator applying on P dagger gives us minus of r cap. P applying on momentum P cap. I am writing parity operator as this just to avoid the confusion with the momentum operator. Okay, now let's come back to our solution. That we already know, we will first prove that for P dagger R in cap P. Okay, so before we move ahead, the one thing which I would like to point out over here, we know that P dagger, the Hermitian conjugate of parity operator is nothing but P dagger is P inverse. Okay, so it's kind of unitary operator as well. Now in the equation, this equation, let me write this equation over here, that is parity over position into parity dagger equals to minus r cap. In a fresh page, we have parity r cap P dagger minus r cap. Now multiply both the sides by P inverse, or let's say P dagger. We will have P dagger P r cap and P dagger P. P dagger we have P. This is nothing but identity operator, and this is also an identity operator, so we are just left with minus r cap. We move this minus sign to the left hand side into P dagger R P. Okay, now we are given, we have to find P dagger R to the power n into P dagger or say parity. So there's a bit of confusion with writing parity and p dagger. It's slightly confusing. Okay, so please bear with that. Now if I write further this as r n times p. Okay, we can use this particular thing that in place of r, if we substitute or let's go with some other direction, that is p dagger, we have I r n times. I have just introduced the identity operator in between. Now p dagger parity dagger r, instead of this I have substituted parity into parity dagger, and similarly for this one it goes up to, at the end we get p dagger parity. Alright, now we get this as identity, but this from the previous page we can see this is nothing but minus r. This is nothing but minus r. This one is also minus r. So we have minus r n times into identity. Okay, now if we take minus from each r outside, so we will get minus 1 to the power n into r n. So we have shown that parity dagger into r cap parity is equal to minus 1 to the power n, minus 1 to the power n into position vector. Now similarly we can show that parity dagger into momentum into parity is nothing but minus 1 to the power n into momentum to the power n. The reason I can directly say this, because on the very first page I have told that the relations of they have the same relations with parity. Okay, so that's why we can directly say, once we have proved that for position, we can say that the same thing will go for the momentum operator as well. So I hope this is quite clear. And one thing we can actually add to this by saying if p dagger a into p as a, then p dagger a to the power n p is a to the power n if p dagger b is to minus b, then p dagger b to the power n, p minus 1 to the power n. These relations are also given in Zettili, and I have worked through those, and I'm just stating over here. So these are the two relations which are important to remember for the parity. So I hope this question is quite clear to you. So thank you for watching the video.